So in the last video we saw the first sum on Morse test. So Morse test, as I said before, is basically just a method to calculate the frictional power and indicated power, and it is generally used in an SI engine. Okay, so we saw the first example in the previous lecture, and in this lecture we will be seeing the second example on Morse test, and then we will be seeing some other methods. Till now, see, we have seen two methods of calculating frictional power: Williams line method and Morse test. In this video we will be looking at the other methods as well. Okay, so first we will start off with this example. So in this example they have given us that the Morse test was conducted on a 4-cylinder 4-stroke petrol engine. The cylinder bore is given as 60 mm, stroke is given as 90 mm, and RPM is 3000. The fuel consumption rate that they have given is 4.465 kg per hour, that is mass flow rate of fuel. They have given the calorific value of fuel as 43 megajoule per kg. So they have taken the readings, but see, there is a slight difference between this sum and the previous sum. In the previous sum, they had given us directly the brake power readings. In the previous sum, they had given us the brake power readings. Here they have given us the brake torque readings. So there is not much difference. You only have to remember one thing. What is brake power? Brake power is brake torque into angular velocity. So what is that? Brake torque into 2 pi n upon 60. And what is this n? This n is RPM, 3000. So that is the only difference. So rather than taking this value directly, what do you have to do? You have to multiply it each time by 2 pi n upon 60. This is the only difference between this sum and previous sum. So it is pretty easy. So what have they given us? When all cylinders are working, the brake torque is 52.5. When first cylinder is cut off, it is 37.8, for second cylinder 36.7, third cylinder 36.4, and for fourth cylinder 37.6. So these are all brake torques. Just multiply it by 2 pi n upon 60 and you will get the brake power for each of these conditions. What are they asking us to find? They are asking us to find the brake power, the indicated power, the BSFC, the ISFC. What is BSFC? Brake specific fuel consumption. So what is the formula? Mass flow rate of fuel divided by brake power. This is what? This is your BSFC. Now similar to BSFC, there will be ISFC. What will be ISFC? ISFC will be mass flow rate of fuel divided by indicated power. Okay? And mass flow rate should always be in kg per hour. And brake power should always be in kilowatt. Similarly over here, indicated power should be in kilowatt and mass flow rate should be in kg per hour. So this is how we will measure ISFC. And the last thing they have asked us to find is the mechanical efficiency. Mechanical efficiency is what? Brake power divided by indicated power. So these are the things that we have to find in this sum. So let us look at how we will proceed. First of all, we have the given data. What is the given data? It is a 4-stroke engine. The number of cylinders is 4. Bore is what? 60 mm. So 0.06 meter. Stroke is 0.09 meter. Engine speed is 3000 rpm. Fuel supply rate, I have converted it from kg per hour to kg per minute. If required, we can also convert it into kg per second. I have just divided it by 60 over here. Again, we will divide it by 60 and we will get kg per second. Calorific value of fuel is given. What is calorific value? Calorific value is the amount of heat energy released on burning unit mass of fuel. Okay, so 1 kg of fuel if we burn, we will get 43 megajoules of energy. This is the total torque. Brake torque when all the cylinders are operating, and correspondingly when 1111 cylinder has been turned off. Okay, so let us move forward. So they have asked us to find what? See, they have asked us to find brake power. So how are we going to find brake power? Just now I told you what is the formula for brake power? Torque into angular velocity. So when all cylinders are working, what is the braking torque? 52.5 Newton meter. That is the SI unit. Into what? 2 pi n upon 60. So substituting this value, n is what? 3000 rpm. Right? 3000 rpm. So substituting these values, we get brake power is equal to what? 16.493 kilowatt. Always remember in exam, whenever you are writing the powers, it should be 3 decimal places. See, that is a general convention. It is not compulsory, even 2 decimal places will do, but if possible, always do 3 decimal places. So that is your break power. Now, how are we going to find indicated power? To find indicated powers, we will have to use those formulas. See, this IP1 is equal to BP total minus BP cylinder 1. See, these formulas. Just a minute. These formulas. We will have to use these formulas. IP1 is what? BP total minus BP cylinder 1. IP2 is what? BP total minus BP cylinder 2, and so on. But in our case, they haven't given us the brake powers directly. So we have to find out the brake powers first. So here we are finding out those brake powers. So brake power total is what? Brake power total is 52.5. The brake torque total into 2 pi n upon 60. BP1 is what? 37.8 into 2 pi n upon 60. The same thing that we did previously. See over here, we are just substituting these values and multiplying each value by 2 pi n upon 60. Why? Because we have to find brake power, and formula of brake power is torque into 2 pi n upon 60. This is torque multiplied by 2 pi n upon 60 and you will get brake power. Okay. So this is what we have done over here, and because of this we get all the brake powers. This is brake power total, right? This should be the same. You have done the same thing. This is brake power when cylinder 1 is turned off. See, I have made a small mistake over here. This should not be BP1. This should be BP cylinder 1. Okay, this should be BP cylinder 1. Similarly, this should be BP cylinder 2, BP cylinder 3 and BP cylinder 4. This is a big mistake on my part. It should be BP cylinder 4. I will make the changes in the PPT, but please remember. See, I have missed the convention over here. So this is BP cylinder 1, cylinder 2, cylinder 3 and cylinder 4. So next, what do we see? To find IP1, we have to do BP total minus BP cylinder 1. Over here I have written cylinder 1. I just forgot to write over here. So please make the necessary changes. So IP1 is what? BP total minus BP cylinder 1, and that is how we get the indicated power generated in cylinder 1. Similarly, we get indicated power generated in cylinder 2, 3 and 4. Now, what is IP total? IP total is the summation of the indicated powers developed in all the 4 cylinders. So we add these 4 values up, and by adding these 4 values, we are getting a total brake power of how much? 19.32 kilowatt. And remember, just to ensure that you are doing it correctly, you should know that indicated power should be greater than brake power. See, our brake power is how much? 16.493. And what is our indicated power? Our indicated power is 19.32. So this is just a sort of a check that your indicated power should always be greater than your brake power. Why? Because friction power is indicated power minus brake power, and friction power can never be negative, right? So that's just it. So using this, we found out the indicated power total. We have already found out the brake power total. The next thing that they are asking us to find is BSFC and ISFC. Very simple. Formula of BSFC is what? Mass flow rate of fuel divided by brake power. Unit is what? kg per hour divided by kilowatt. So I substituted the kg per hour, 4.465. It is already given to us in the question itself, right? 4.465 kg per hour. I just divided it by the brake power that we found out. Here we found out the brake power. Substituting that, we get brake specific fuel consumption. Similarly, to find indicated specific fuel consumption, it is mass flow rate of fuel divided by indicated power. That is indicated specific fuel consumption. And the last thing that they have asked us to find is the mechanical efficiency. So mechanical efficiency is what? Brake power upon indicated power. Substituting the values, we get 85.36%. So see, overall these sums are not that difficult. The only thing that you have to keep in mind always is this part, right? Is this part. Indicated power developed by cylinder 1 is what? Brake power total minus brake power cylinder 1. And similarly for all these cylinders. This is what, if you keep in mind, you will be able to solve any Morse test sum. Okay. So this was the Morse test. So basically, why are we doing Morse test? Why are we doing this Williams line method? These methods are done to find out the frictional power. If you remember this slide from our first lecture, third lecture of this module, so it is easy to find the brake power. Brake power can be found out very easily using a dynamometer. To find frictional power, we use these methods. We use Williams line method, we use Morse test, and we use motoring test. And using these two, substituting it in this equation, we can find the indicated power of the engine. Now we have seen Williams line method, we have seen Morse test. Now we will see motoring test. Now motoring test is also quite easy, quite understandable, not that difficult. Motoring test works on the principle that a motor is both. See, a dynamometer can act as a motor and a motor can act as a dynamometer. Initially, what we do, initially we drive the engine, we supply fuel to the engine is running, and because of the engine, this dynamometer is running, right? Means what is happening, the dynamometer is providing the load and the engine is working against this load provided by the dynamometer, right? And that is how we measure the brake power of the engine. But what happens, see, initially, okay, I will explain it once again. See, what is happening, initially, this is your engine, it is working. We are sending in fuel, we have, this is our dynamometer. In this dynamometer, we have applied some load. This applied load is working on this engine and the engine is producing power against this applied load. And that is why we can measure the brake power of the engine. What do we do next? What do? We let this engine run for some amount of time. Let us say we let this engine run for 5 to 10 minutes. In these 5 to 10 minutes, what happens? The inner coolant settles to a fixed temperature. See, the coolant warms up, then it is at a fixed temperature, remains at a fixed temperature. Similarly, the lubricant works at same temperature. So it is like it. So the engine basically reaches a stable system. The coolant inside, the lubricant inside reaches stable system. So we allow the engine to operate for some time, say 5 to 10 meters, 5 to 10 minutes. And during that time, we take the brake power reading of the engine. So we know the brake power of the engine because of this dynamometer. Now next thing what we have to do, next thing we have to find out the friction power of the engine. So what do we do? What we do is we turn off the fuel supply to the engine. Whatever the fuel supply was coming into the engine, we stop that fuel supply to the engine. Because of that, what is going to happen, as soon as fuel supply to the engine is stopped, is the engine going to produce any power? No, the engine is not going to produce any power now. But at the same time, just as we stop the fuel supply to the engine, we hit another switch. And what this switch does is, this switch converts this dynamometer into a motor. This switch converts this dynamometer into a motor. What does that mean? Initially, this was acting like a dynamometer and it was measuring the brake power of the engine, right? Then when we hit a switch, the fuel supply is stopped and at the same time, this dynamometer starts acting like a motor, right? What is the function of a motor? A motor rotates. So what is this motor going to do? This motor is now going to rotate this engine. Ideally, what would have happened? Imagine if this dynamometer was not able to convert into a motor. What would have happened? As soon as we had cut off the fuel supply, this engine speed would have gone on reducing, right? This is what would have happened. But what we do, as soon as we cut off the fuel supply, there will be a slight dip in engine velocity. But at the same time, we start this motor and this motor continues to run the engine at the same RPM. This motor continues to run the engine at the same RPM. What was the RPM that we agreed upon? Say 1500 RPM. Initially, the engine itself was running at 1500 RPM. Now when we stop the fuel supply and we start the motor, now the motor is running the engine at 1500 RPM. Now imagine what is happening inside the engine. Inside the engine there is no combustion, means there is no indicated power being developed. What is the only force against which this motor is rotating the engine? What is the resistive force on the motor? Barabar, means what I mean to say, this motor has to work against what force? That is the frictional force inside the engine. So by measuring what is the power absorbed by this engine, see what by this motor. See, this is the motor, this is my engine. Now my engine has stopped working. Engine is not operating. Engine, there is no fuel coming inside the engine, hence there is no combustion. What I am doing, I am taking electric supply. There is some electric supply. This is my electric supply. From this electric supply, this motor is taking electricity. And using this electricity, this motor is running this engine at the same RPM as it was running before, 1500 RPM. So what is the force, what is the power which is being developed by this motor? That power is equal to the frictional power of the engine. Why? Because the engine was initially running at 1500 RPM. That was when inside combustion was taking place. Now combustion has stopped. What is the only thing which is stopping this motor, stopping this engine slowly and slowly? It is the frictional power of the engine. For example, see in your fan, initially when the fan is on, it is rotating because it is absorbing electricity from our main supply, electric supply. Afterwards, what happens when we turn off the fan? The fan keeps on rotating for some amount of time. The fan keeps on rotating, but afterwards it slows down and stops. Why is it stopping? Because of the frictional forces and the air resistance. So the power lost by the fan is because of what? The friction power. But if we want to keep on rotating the fan at the same velocity, if we are rotating it with our hand, how much power should we give with our hand? That power should be equal to the frictional power of the fan. That same thing is being done in this case. In this case, the fuel supply to the engine is stopped, but we keep the engine rotating at the same RPM. To keep the engine rotating at the same RPM, what we do? We run this motor. And this motor, the amount of power used by this motor, the amount of electric power used by this motor is equal to what? Is equal to the frictional power of the engine. Okay. And to find out what is the electrical power absorbed by motor, there is a simple formula for electric power. See, in our case, what is the formula for power? In mechanical, formula for power is Bp is equal to 2 pi n upon 60 into torque. Similarly, in electricity, if you want to find out the amount of power which is being used by the motor, the formula is simple, voltage into current. So we have to find out what is the voltage inside this motor and what is the current flowing inside this motor. To do that, we use these two devices. This first one is a voltmeter and the second one is your, this is your voltmeter and this one is your ammeter. Okay, this is your ammeter. So using ammeter, we are measuring the current. Using the voltmeter, we are measuring the voltage, and voltage into current is the electric power, right? This is the electric power, and this electric power is equal to the frictional power of the engine. This electric power is equal to the frictional power of the engine. So I will explain it once again completely. How does a motoring test occur? In a motoring test, first of all, we have our engine. We operate the engine till it reaches a certain fixed RPM. Let us say 2000 RPM. Then what do? We allow the engine to run for 5 to 10 minutes. During this time, we measure the brake power of the engine using this dynamometer. Then what do? We turn off the fuel supply to the engine. And at the same time, we hit a switch that converts this dynamometer into a motor. What is happening? The engine should ideally slow down, but the engine does not slow down. Why? Because this motor keeps on running and keeps the engine at the same RPM. Where is this? So engine is absorbing the energy from the motor. And where is the motor getting its electricity from? Energy from? Motor is getting its energy from the electricity supply. And to measure how much energy, how much electrical energy the motor is using, we use a voltmeter and an ammeter. So using this voltmeter and ammeter, we measure what is the electrical power. And this electrical power is equal to the friction power of the engine. In this way, we can measure the frictional power of the engine using motoring test. So in motoring test, you get both brake power and you get the frictional power. By adding brake power and frictional power, you can also get the indicated power. Okay, so this is another method which is used with Williams line method. You can use Williams line method, you can use Morse test, you can use this motoring test. All these three methods are used to measure friction power. See, whatever I just explained, the same I have explained it over here. I have written it down over here. You can read it. Okay. The last method to measure friction power is by measuring the brake power and indicated power separately and then using this formula. See, as I explained to you before, what is the main reason that we cannot find indicated power easily is because finding the indicated power is difficult. We have to use this indicator diagram mechanism. Okay, so it is not very easy, but nowadays because of the good sensors, because of highly responsive sensors, we can find out the indicated power more easily than before. Let's say 20 years ago it was very difficult. Now it is slightly easier. So nowadays during engine testing, what we do means what people do, they find the indicated power, they find the brake power, then they subtract indicated brake power from indicated power. They find IP, they find BP, and they subtract BP from IP, and that is how they get FP. At the same time, they also use some other method, for example, Morse test, or example, Williams line method, or motoring test, and they find the friction power by that method also. And they check if these two values are close by, right? They will not be exactly equal. No machinery is so perfect, but they should at least be close by. By doing this, they cross verify that their calculations are correct. So this is what happens nowadays. So this method is the probably the easiest method for friction power, but measuring indicated power is difficult. Indicated power is measured using this method, using indicator diagram or using your sensors to draw the PV graph, and using the area under the graph you can find out the indicated power. And brake power is simply measured using this dynamometer. So this is how the engine performance is measured. See, basically what was the point of all these lectures till now? It was to teach you how the engine power output is exactly measured in industries, right? Because we have to do the testing of engine to make sure that the engine is producing the required amount of power. If the engine is not creating the required amount of power, the car will not move at what speed we want. There will be stalling of the car. The car will not be able to accelerate very fast. That is why all this testing is done. And using these powers, indicated power, thermal power, brake power, and frictional power, we can calculate the various engine efficiencies such as brake thermal efficiency, indicated thermal efficiency, mechanical efficiency. And using these efficiencies, we can check whether the performance of the engine is as required or not. Okay. So that was the point of this entire module. Hopefully you have understood most of these things. If you have any doubt, you can definitely contact me for that. Okay, thank you.